Okay, in this short video, I'm going to go through the solution to the problem of the week for the first week of February. I took this problem, I think, from the 2009 Gauss math contest. So the Gauss contest is based on the grade 8 curriculum. I think this was one of the tougher, like one of the last problems on that math contest. So Chuck is a llama. Unfortunately, he's been, I don't know, captured, or someone owns him. He's a pet. I don't know. I don't know what llamas do. But he's tied to a shed, and he's on a leash that is 3 meters long, and the shed is 3 by 2. So this has been on Brightspace for a few days. I hope everyone's had a chance to try the question. I'm just going to walk through one solution that works. First, let's look at the case where Chuck isn't tied to a shed. Chuck is only tied to a post, and he's got a 3 meter leash. So we want to figure out what is the total area that Chuck can play in. Well, he can walk 3 meters in any direction from that central post. If you kind of think about this, this is all of the different paths that Chuck can take, which traces out the shape of a circle. Actually, that's the definition of a circle in math. Every point on the circle is the same distance from that center. And our radius of this circle is, of course, the length of the leash, or 3 meters. And we know that the area of a circle is pi r squared. So if r is 3, then the area of this circle would be 9 pi meters squared. So if Chuck was only tied to a post, he could play in 9 times pi meters squared. 9 pi is around 28 square meters of space. Chuck is not that lucky. Chuck is tied to a shed. So there's the shed, 3 by 2. If Chuck goes to the left, he can still go all the way to the edge of that circle that we traced out earlier, because the shed is 3 meters and so is his leash. And if he goes to the right, he can go all the way down to the bottom as well. So he can definitely cover 3/4 of his original circle without really running into any problems, without running into the shed. So we know that this red shaded area is 3/4 of the original 9 pi. But Chuck can still go further. So 2 meters of his leash are going to be tight or taut against the side of the shed, but he still has 1 meter of slack that he can drag around with him. So I've drawn this kind of purple. That's the extra 1 meter at the end of his leash that he can pull in another circle. You can kind of think of the center of this small circle as being that bottom right corner of the shed. He can pull the leash around that corner, carving out that new quarter circle that's got that radius now of 1 meter. He can walk all the way around this red 3/4 circle, and then he can also go in this little purple quarter circle, because he's got that extra 1 meter of slack in his leash. Well, how much is that purple shaded area? Well, the radius of that quarter circle, or that circle, is 1 meter. So pi r squared would just be pi times 1, or just pi. And it's only 1/4 of that circle, so it'd be pi over 4. So the total area that Chuck can travel in is that 9 pi times 3/4 plus pi times 1/4. That's the smaller purple quarter circle. So I can do some fraction multiplication. So I've got 27 pi over 4 plus pi over 4. I've got 28 over 4, which reduces to 7 pi meters squared. So Chuck can play in 7 multiplied by pi meters squared, and that's his area that he can play in while still being tied to his leash. One other thing I wanted to mention, I saw a lot of your solutions, which were great attempts at the problem. A lot of you wrote your answer as a decimal. So you actually punched in the value for pi. You either use 3.14, or maybe you have a pi button on your calculator. 7 pi is actually the preferred way to leave the answer. We call that an exact answer, because it tells us exactly what the value is. If I have to use pi as a value, then I need to round it, because pi goes on forever. So the approximate answer is around 22.99 meters squared, but I'd prefer it if we always left things in what's called exact form. That also tells us a bit more about how we arrived at the answer. So that's your first problem of the week, taken from the Gauss math contest, and pretty similar to a lot of math contest problems where it's curriculum or math content that you know, but maybe pushing you to explore it or to experiment with it in some new directions. And I always find that doing a diagram is a good way to start some of these questions. Okay, let me know in the comments if you had any questions or concerns about this question, or about the way that Chuck the llama is treated in captivity.